Welcome guys to the best math channel in the world. So on Bizzy made it easy channel, the only channel exam fear when it comes to mathematics. This is the only channel we make mathematics fun for everyone to understand. If today is your first time seeing us, don't forget to hit the subscribe button, like, comment and share for everyone to have a benefit of it. We teach maths from the lower level to the higher level for everyone to understand. One trick and advice I'll give you is that to know mathematics is about constant practice and determination. So you have to be ready that you know it. Yes, to know math is not by luck or something. It's about constant practice. We all came to this earth to learn. So I believe with constant practice, you will be good. And today we are going to have our fifth lesson on the coordinate geometry. Every topic I pick, I make sure I teach it to the lowest level or to the last level so that any question the exam body set on that, you'll be able to answer. And we go deeper and we combine both further math and normal core math for everyone to understand and get the concept. Now, today, without wasting much time, we are going to talk about collinear points. Collinear point, perpendicular lines, and application to parallelogram. Parallelogram. Yes. So it's 3-in-1 lesson we are going to have today as well. So I'm going to start with the collinear point. I'm going to start with the collinear points. Now, how do we say, or how do we determine if two or more points are collinear? They are collinear when they lie on the same straight line. So when you have your linear graph like this, and you have points A, B, C, D, and E. If these points are found on the same line, we say they are collinear. And how do you prove that? We prove that by calculating the gradient of any of the numbers or any two of the points here on the line. So when you calculate for the gradient of any of these and you get the same gradient, we conclude by saying that the 2 points or the point you have picked are what? Collinear. As simple as that. And what you need to understand is that in the linear graph, a graph with a straight line, any 2 points you pick, you must get the same gradient. Yes, any point you pick. In the last part of the video, there will be a mini graph, a mini line, then we are going to determine the gradient of the line irrespective of where we pick the point. So keep watching and subscribe. Now, if you pick the point here and point here, maybe they will give you 3 points to determine the gradient. So they will give you point A, B, C. Then they will tell you to determine if A, B, and C are collinear. Yes, and I've told you, if they have the same gradient or same slope, you conclude by saying the points are collinear. And we are progressing. And here we see we have mentioned gradient here. In my previous video, we did application to triangle. Yes, to determine the type of triangle using the distance formula. And math is not about learning and forgetting. So whilst you are moving forward, when you see any question, you should know the formula applied. See here, the gradient has come again. So if you have forgotten the gradient formula, you are going to struggle here. That's why constant practice is very, very necessary when it comes to mathematics. So we are not going to waste my time here. We are going to take our first question on the collinear concept. It says show the points 0, 0, 3, 5, and 21, 35 are collinear. Or show that the points 0, 0, 3, 5, and 21, 5 are collinear. So I'm going to write a point here 0, 0, 3, 5. Then I have 21, 35. They say we should show that they are collinear, or we should show if they are collinear. Yes. How do we determine if they are collinear? We have to find the gradient. So I'm going to name this 0, 0 as A. then the 3, 5 as B, then the 21, 35 as C. So we are going to compare gradient at the 2 points. So I'm going to combine A, B and B, C. Yes, I'm going to pick these 2 points. Yes, A, B and B, C. A, B and B, C. Now A is 0, 0. Now B is 3, 5. Yes, and we know the gradient of a line. Now the gradient, which is small m, what's the formula? It's y2 minus y1 all on x2 minus x1. Now according to the point here, so x1 is 0, y1 is 0. Now x2 is 3, y2 is 5. Yes, x1 0, y1 0, x2 3, then y2 is 5. So let's put it back into the formula. So y2, 5 minus y1, which is 0. Then x2, which is 3, minus x1, 0. So 5 minus 0 is 5. All on 3 minus 0 is also 3. So the gradient of AB is 3, 5. Gradient of AB is 3, 5. Now let's find the gradient of BC. So gradient of BC. So point B is 3, 5. Then point C is 21, 35. Yes, 21, 35. Now follow closely. So here our x1 is 3, y1 is 5, x2 is 21, then y2 is 35. So the gradient, which is small m, is y2 minus y1. Then we have x2 minus x1. So we are going to put them back into the formula. We are going to put the numbers back into the formula. So follow closely. So what's our y2? 35. Then our y1 is 5. Our x2 is 21 minus x1, which is 3. Now 35 minus 5 will give us 30. Now look here. Now we have 21 minus 3, which is going to give us 18. Now can we simplify this number? Yes. Let's simplify with 3. 3 can divide here 10. 3 can divide here how many times? 6 times. Now we can simplify again. 2 can divide here 5. 2 can divide here 3. Now we have 5 on 3. So gradient of BC. Now what do you see here? So the gradient of AB we got 5 on 3. The gradient of BC we got 5 on 3. So what do we see? So therefore we conclude by saying line A, B and BC are what? They are collinear, as simple as that. Line AB and BC are collinear, or you can say that line ABC are collinear or collinear point. Yes, assuming we got different gradient. If we got different gradient, then we conclude by saying line AB and BC are not collinear. So points are collinear when they are on the same line and they have the same gradient. Simply, this is how we determine if given points are collinear. Now let's take the next question on this. 3, 3, 1 and 5, 9 are collinear. So we should show whether they are collinear. Your answer will determine that. So the first point were 2, -3. Then we have 3, 1. Then we have 5, 9. Yes, we should show that they are collinear. So I'm going to use different letters. M, 2, -3, N, 3, 1, and O, 5, 9. So I'm going to combine Mn and NO. So Mn and NO. So point M here, 2, -3. Then N is 3, 1. So we are going to find the gradient. So x1 is 2, y1 -3, x2 3, y2 is 1. So follow closely. So our gradient, which is small m, is y2 minus y1, x2 minus x1. Now what's our y2? y2 is 1 minus y1. y1 is having negative. So I've told you it's going to be in bracket. When the number has a negative and there's a negative in the formula, the second one will be in bracket with a number. Don't forget that. So we have 3 here minus 2. So the top one, negative will be positive. I will do that one, then I'll repeat the down one. 3 minus 2. So 1 plus 3 is 4, all on 3 minus is 1. Yes. So which is equal to what? 4. So the gradient of line Mn is equal to 4. So line Mn, we have gotten a gradient of 4. So let's find the gradient of NO. So N is 3, 1. Then O is 5, 9. So let's identify our x and y coordinates. So y1 is 1. So x2 is 5. y2 is 9. So this is 9. So the gradient so y2 minus y1, x2 minus x1. So our y2 is 9 minus y1, 1. Sorry, y2 is 9, y1 is 1, then x2 is 5. Then x1 is what? 3. So 9 minus 1 is 8. Then 5 minus 3 is 2. For which when you simplify, you are also going to get 4. So gradient of NO is also 4. Now what do you see here? Here the gradient is 4. Here to the gradient is 4. So what do we do here? We conclude. So the line M N O, or the point, the line or the point, so let me repeat it, 2, -3, 3, 1, and 5, 9 are what? They are collinear. Yes, they are collinear. So when do we know if they are not collinear? If they are not collinear, we'll get a different gradient for them. Here can be 9, here can be 8, here can be -4, here can be 4. When we get different answers, it means that they are not collinear. Simple as that. Let's take the next question on that. So our question says, show that 6, 1, 3, 3 and -3, 7 are collinear. So as we know, 6, 1, 3, 3, then -3, 7. We should show that these points two are collinear. So I'll use letters for them. So X says 1, Y 3, 3, and Z negative 3, 7. So I'll combine my XY and YZ. So the gradient of XY, gradient of XY, with the gradient of XY with the X. So X1 is 6, Y1 is 1, X2 is 3, Y2 is 3. So the gradient formula is Y2 minus Y1, X2 minus X1. Now what is our Y2? Y2 is 3, Y1 is 1, X2 is 3 again, Y1 is 1. So Y2 is 3, Y1 is 1, X2 is 3, X2 is 3. Then X1 is negative 6. Sorry, X1 is negative. So the top one will give us 2 on negative 3. So the gradient of XY is negative 2 on 3. The negative affects both of them. So just put it in the middle. So a negative dividing positive, now you get a negative. So when we write it like this, it stands for this. So the gradient of XY has given us negative 2 on 3. Now let's find the gradient of y, z. So the point y, what are the points for y? Y is 3, 3. Z, negative 3, 7. Yes, negative 3, 7. So let's identify our x and y coordinate. X1 is 3, Y1 is 3, X2 is negative 3, Y2 is 7. So gradient Y2 minus Y1, X2 minus X1. Now Y2 is 7 minus Y1 is 3. X2 is negative 3 minus X1, which is 3. So 7 minus 3 will give us 4. Then negative 3 minus 3, you were owing 3, you want to borrow again. The calculator, when you punch, but without calculator, you should understand. So negative 3 minus 3 will give negative 6. So we can simplify. 2 can divide here, 2 can divide here. So this 2 has given us negative 2 on 3. The same gradient. Yes, the same gradient, meaning these 2 points too are collinear. So we conclude by saying, therefore, the points 6, 1, 3, 3, negative 3, 7 are collinear. As simple as that. So determine whether lines are collinear is very simple. It's a matter of knowing your gradient formula, as we have done in my previous video, then comparing the gradient of 2 pairs of the given point. So this is how we solve or prove to show that 2 or more points are collinear. Let's take the next question. So the last question is the points 2, negative 3, 3, negative 1, and 4k lie on the same straight line or lie on a straight line. Find the value of k. Find the value of k. Say the point 2, negative 3, then 3, negative 1, and 4k. They're on a straight line. If they're on the straight line, something should come into your head. it means they will have the same gradient. Yes, they will have the same gradient. So they say we should find the value of A. How do we do that? So let me label this one as Q. 2, -3, R, 3, -1, and S for K. So I'm going to find the gradient of Q R. Yes, for which Q, so gradient of QR, gradient of QR. So Q, 2, -3, then R, 3, -1. So X1 is 2, Y1 is -3, X2 is 3, then Y2 is -1. So follow closely. So gradient, so Y2 minus Y1, X2 minus X1. And as I solve, you can pause the video and solve and see if we will all come to the same answer. So Y2 is -1 minus Y1 is -3. All over X2 is 3. Then X1 is what? 2. So the top one give -1, negative will be positive. I prefer doing that before I move to the next one. -1 plus 3. You're owing 1 and you paid with 3. So there will be +2. Then 3 minus 1 is 1. So the answer is 2. So the gradient of line QR, we've gotten what? 2. The gradient of QR, we have gotten 2. Yes, so QR, we have gotten 2. Let's find the gradient of RS. So R, 3, -1, then S is 4, K. So here our X1 is 3, our Y1 is -1, our X2 is 4. Now our Y2 is what? Is K. Now follow closely. So gradient. So Y2 minus Y1, X2 minus X1. Don't be confused because I've left the M. Yeah, sometimes I can bring it, sometimes I can leave it. If you want to write only the M, in coordinate geometry, we understand its gradient. But I prefer you writing that gradient or the M. We can get along with it. So the Y2 is K minus Y1, -1, all on X2, 4, minus X1, 3. Now, the top one give us K plus 1, all on 1. K plus 1, all on 1. Now, they say we should find the value of K, but we have arrived here. So how do we proceed to find the value of K? And what we need to understand is that the gradient of line QR should be equal to the gradient of line RF. So far as the line on the same line or the points are on the same line, they should have the same gradient. And since we know the gradient of QR, we have to bring it here. So in this one, the gradient here, which is 2. So the gradient of QR will be equated to K plus 1, which will be the gradient of what? RS. This is the gradient of RS. So we are going to put the gradient of the QR here. So 2 is equal to K plus 1 all on 1. So what do we do here? We can cross multiply. So this is over 1. So this element multiplying by 1, you get the same to clip K plus 1. Then this 2 times 1 will also give us 2. Now follow closely. So we have our k, or let me even continue here. Let me continue here rather. So now I've gotten k plus 1 is equal to 2. So equation 2, k is equal to 2 minus 1. So k is equal to 1. So therefore the value of k is equal to 1. The value of k is equal to 1. This question looks a little tricky, but what you need to understand is that when points lie on the same line, or when points are on the same line, they must have the same what? Gradient. They must have the same gradient. So far as you've calculated for the gradient of the other one, we've gotten a perfect number. And when we reach here, we have to find the value of k. So the gradient that is missing here, we can replace it with the gradient of the QR. Yes, we can replace it with the gradient of the QR. So this is how we solve this. And all the questions I've selected are past questions. Yes, past questions. So you solve, you can restart the video, or you can start the video, pausing and solving to see if you get the same answer. Yes, so this ends the lesson on finding collinear point. So we are continuing with perpendicular lines, then with the application to parallelogram. Don't forget to subscribe, recommend and share the Bizzy Made It Easy channel on all social media platforms, Facebook, Instagram, everywhere. Then you learn mathematics to your maximum satisfaction. So we are continuing perpendicular lines. So when do we determine if 2 points are perpendicular? Or when do we say points are perpendicular? Yes, so if I have perpendicular lines, I'll have this point B, C, and D. So this point here, how will I know if a point is perpendicular to the other? Yes, how will I know a point is perpendicular to the other? A point is perpendicular to each other when the product of their gradient is -1. The product of their gradient is -1. In mathematics, what problem? Product is what? Multiplication. Yes, the product of their gradient. So if this is L1 and this is L2, so it means the gradient of M1 times the gradient of M2 should give me -1. So anytime you solve given point, with the other one we got 3 points, so this one will be given 4 points. So we calculate for the gradient of each pair. So like A, B, C, D. So if you multiply their gradient and you get -1, then it means these two lines are perpendicular to each other. As simple as that. So we are going to take a question to see how that 1, 2 is calculated. The question is on the screen. Given the point A, -1, -1, B, 0, 4, P, -4, 3, then Q, 6, 1. Find whether or not AB is perpendicular to PQ. Find whether or not. So they can be perpendicular or they cannot be perpendicular. So the points are A, -1, -1, then B, 0, 4, then we have P, -4, 3, then Q, we have 6, 1. So what we have to do is we are going to find the gradient of AB. Gradient of AB. So point A, -1, -1. Point B, 0, 4. So let's locate our coordinates. So x2, 0, y2 is 4. So the gradient formula y2 minus y1, x2 minus x1. Now what is y2? 4. What is y1? Negative 1. All on x2, 0. x1, negative 1. So 4, this will give me plus 1. Sorry. All on 0 plus 1. You do this, it will help you with the calculation. Calculator will give you straight answer, but I'm proving why the calculator gives certain answers. So the top one give us 5, the down one will give us 1. So we got 5 here. So the gradient of AB is equal to 5. Now let's find the gradient of PQ. The gradient of PQ. So our P, negative 4, 3. Then our Q is 6, 1. So x1 is negative 4, y1 is 3, x2 is 6, y2, sorry, is 1. So gradient y2 minus y1, x2 minus x1. Now y2 is what? 1. y2 is 1, y1 is 3. Then x2 is 6 minus x1, negative 4. So the top one will give me negative 2. 1 minus 3. Then, okay, since the down one is there, let me repeat even here. So I'll get 6 plus what? 4. Now, the top one will give me negative 2 all over. Then, the down one will give me 10. For which one to simplify? This will divide the 1, divide the 5. So negative 1 on 5. So gradient of EQ is negative 1 on 5. Now let's find their product. Their product. So their product, I'll say M1 times M2, for which you understand. Small m is gradient. So M1 I got 5 times M2, negative 1 on 5 is negative 1 on 5. So multiplication of fraction by a whole number. So this can divide this one, this can divide this one. So the top one, we have 1 times negative 1, which will give us negative 1. When you point straight to the calculator, you get negative 1. Now what do you see here? We have gotten their product as what? Negative 1. So therefore, we conclude by saying the line AB and PQ are what? Perpendicular. As simple as that. So when you finish, find their product. When you find their product and you get negative 1, you see that the 2 points are perpendicular. This is a Young Busy Made It Easy channel. Don't forget to subscribe. So let's take the next question. Between the point Q14, R66, S2 negative 1, and T12, 3, show whether or not QR is perpendicular to ST. So we have point Q 14 excuse me, R66, then S 2 negative 1, then we have T 12, 3. So we are going to find the gradient of QR. So QR. So our Q is 14, our R is 66. So X1 is 1, X2 is 6, Y2 is 6, then Y1 is 4. So X1, X2, Y2, Y1. I've interchanged it, so don't be confused. So our gradient formula, y2 minus y1, x2 minus x1. What is y2 here? y2 is 6 minus y1, which is 4. Then x2, 6. x1 is 1. So 6 minus 4 is 2. Then 5 minus 1 is 5. So the gradient of QR is 2 on 5. This way. So let's find the gradient of ST. So our S, 2 negative 1, our T is 12, 3. So now we are going to find the gradient of ST. So now x1 is 2, y1 is negative 1. Then x2 is 12, then y2 is 3. So our gradient, y2 minus y1, x2 minus x1. y2 is 3 minus y1, negative 1. x2 is 12 minus x1. Okay, so the top one give me 3 plus 1. Then the down one will give me 10. Okay, let me repeat that one too because of the top one. So I'll get 4 on 10, for which when I simplify 2 divided 2, so this one give me 2 on 5. Yes, 2 on 5. I've gotten 2 on 5. So the gradient of ST has given me 2, 5 as well. So their product. I have the first gradient and the second gradient. So the first gradient is 2 on 5 and the second gradient 2 on 5. Multiplication of fraction. We check if we can cross divide. Cross divide. So if we can't, we multiply them straight away. So the top one give me 4 all on negative 25. Can any number divide the top and the down one? No. So now their product, I've gotten 4 on 25. If I've gotten 4 on 25, we are looking for negative 1 for them to be perpendicular. So we conclude by saying the points Q, R, and ST are not perpendicular. They are not perpendicular. Because they will be perpendicular if the the product of their gradient is negative 1. So these 2 points are not perpendicular. So we are taking the last question on this. On the perpendicular, show that the 2 lines. So the next question is show that the 2 lines 3x plus 5y minus 8 is equal to 0 and 5x minus 3y minus 3 is equal to 0 are perpendicular. So the lines, we have 2 lines. 3 plus 5y minus 8 is equal to 0 and 5x minus 3y minus 11 is equal to 0. We should show that these 2 lines are perpendicular to each other. Don't get confused here. The other ones we did, they were giving us 4 points for us to find their gradient and find the product and determine if they are perpendicular, expecting an answer of negative 1. Now with this part or with this question, they've given us equation of the line, and when they give equation of the line, you know how to find the gradient. There's a lesson on that. So you can check that in the playlist of coordinate geometry on my channel. So this one, we have to find the gradient, and we know to find the gradient, we have to leave the equation in this form. Y is equal to mx plus c, and the number attached to the x becomes the what? The gradient. So let's solve for this. So line 1, the first line. So 3x 5y minus 8 is equal to 0. So since we are making y the subject, I'll leave the y here. So 5y is equal to 0. Then plus 8. This coming will be minus 3x. So 5y will be equal to 8 minus 3x. So we are making y the subject. So I'll divide both sides by 5. Both sides by 5. And y is equal to 8 on 5 minus 3x on 5. We have made y the subject. So it means the number multiplying the x becomes the gradient. So the gradient of line 1 is negative 3 on 5. So this is the first gradient of line 1. So let's find the gradient of line 2. So L2, which is 5x minus 3y minus 11 is equal to 0. We are still leaving our equation in the form y is equal to mx plus c. So 5x minus 3y minus 11 is equal to 0. So here too we have to make y the subject here. So I'll leave the negative 3y. Since the negative is affecting this one, I'll send the rest. So I have 0 here minus 5x plus 11. This negative crossing. So negative 3y is equal to, here will give you negative 5x plus 11. Since I'm looking for y, I'll divide both sides by negative 3. Negative 3, negative 3, negative 3. So this takes this takes this. Now y? So negative, negative with positive. So I have 5x on 3. Then plus. Now, look here. Negative and positive dividing. So it's going to be negative 11 on 3. So be very careful here. So negative, positive is going to be negative. So the gradient of L2, line 2, is 5 on 3. So this is a gradient of L1, this is a gradient of L2. So let's find their product. So their product will be L1 times L2, which is the first gradient times the second gradient. So negative 3 on 5 times 5 on 3. Now we can cross divide. 5 divide here 1, divide here 1, 3 divide here 1, divide here 1. So now I have negative 1 times 1 all over 1 times 1. So 1 times 1 is negative 1, then 1, which will give me negative 1. So I've gotten negative 1. So therefore the lines 3x, 3x plus 5y minus 8 is equal to 0. And the next one is 5x minus 3y minus 11 is equal to 0 are perpendicular. Interesting. So you should know what you are doing. When they give you equation of the line, you know how to find the gradient. And when points are given, you should know how to find the gradient. It has been simplified on my previous lesson. So this is the end of finding whether points are also perpendicular. So we are going to solve our last question, which we are going to show that some points are points on a parallelogram. So don't forget to subscribe, share, and recommend to all students. Let's continue. We have to show that given points are vertices on a parallelogram. Yes. So we know parallelogram. So parallelogram, yes, quadrilateral with the opposite side being parallel to each other. Yeah, so this side is parallel to this side is also prior to this. So how do we show that given points are vertices on the parallelogram? So if you have A, B, C, and D, so AB is parallel to this. So how do you know that given points are vertices on the parallelogram? To determine that, when you find the gradient of AB and find the gradient of CD and they are the same, they show that those vertices are points, or they are vertices of what? Those points are vertices of what? A parallelogram. As simple as that. So when you see any question and they give you a point and they say show that they are vertices on a parallelogram, simply put, this is how it is solved. Yes, so we are not going to waste my time on this. We are going to solve only one question on this. Well, it's very, very easy to question on that. So they say we show that A 6 negative 2, B negative 2, negative 4, C 0 2, and D 8 4 are vertices on parallelogram. So A was given as 6 negative 2. So B was given as negative 2 negative 4. Then C was given as 0 2. Then D was given as 8 4. So these are the vertices. So we have to find the gradient of AB. And my A is 6 negative 2. My B is negative 2 4. So x1 is 6. Y1 is negative 2. X2 is negative 2. Y2 is negative 4. So gradient Y2 minus Y1, X2 minus X1. So Y2 negative 4 minus Y1 negative 2. So X2 negative 2 minus X1 6. So the top one will give negative 4 plus 2. Then this one will give us negative 2 minus 6. So negative 4 plus 2 give me negative 2. Then all over negative 2 minus 6 will give me negative 8. Negative takes negative. You can divide here 1, divide here 4. So the answer is 1 on 4. So the gradient of line AB is 1 on 4. The gradient of line AB is 1 on 4. Let's find the gradient of CD. The gradient of CD. So C is 0 2, then D is 8 4. X1 0, Y1 2, X2 is 8, Y2 is 4. So gradient Y2 minus Y1, then X2 minus X1. Y2 is 4 minus Y1 2. Then X2 is 8, X1 is 0. So 4 minus 2 is 2. 8 minus 0 is what? 8. You can divide here 1, divide here 4. So gradient of CD is also 1 on 4. So this S, we've gotten the same gradient. So if you have gotten the same gradient, you conclude by saying, therefore, since the gradient of AB is equal to the gradient of CD, we say that A, B, CD is a parallelogram or vertices of a parallelogram. So when you see any question, they say show that these points are vertices of a parallelogram. This is how we solve it. Find the gradient of each pair, then compare it. If they are the same, they are vertices. If they are not the same, they are not vertices on the parallelogram. This brings us to the end of today's lesson. If today is your first time, don't forget to subscribe to Say on Busy Made It Easy channel, the best math channel in the world. Recommend and share to everybody on all social media platforms. Follow us on Facebook. We have been posting TikTok, then on YouTube. There are short videos, then there are playlists for all lessons. Don't worry, we will make mathematics easy, and the fear of mathematics will be a thing of the past by the help of Say on Busy Made It Easy channel. Until we meet again, say goodbye for now.